Start the problem. Faudan Kumar, the video is on. Sorry, Loyal, not Faudan. Loyal.
Sir.
Okay, so we have started video. Okay, now the recording started, not a problem. Next is we have to continue this problem. So just a minute, the pen is not working. Hello, Nitish Ray. ಅದು ಪೆನ್ ವರ್ಕ್ ಆಗ್ತಿಲ್ಲ ಅಂದ್ರೆ ಚಾರ್ಜ್ ಇದೇನು ಏನು ಕನೆಕ್ಟ್ ಇದು ಆಗ್ತಿಲ್ಲಪ್ಪ ಚಾರ್ಜ್ ಆಗ್ತಿಲ್ಲ ನಾನು ಇದು ಮಾಡ್ಲಿಕ್ಕೆ ಬರೀಲಿಕ್ಕೆ ಆಗ್ತಾ ಇಲ್ಲ 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 ಟಚ್ ಆಗ್ತಿಲ್ಲ ನಾನು ಈಗ ಬಂದೆ ಅದು ಬಿಗಿನಿಂಗ್ ಅಲ್ಲಿ ಒಂದು ಸ್ವಲ್ಪ ಟಚ್ ಆಗ್ತಿತ್ತು ಈಗ ಮತ್ತೆ ಆಗ್ತಾ ಇಲ್ಲ ಇಲ್ಲ ಯಾವ್ದು ಟಚ್ ಮಾಡಿಲ್ಲ ಟೂಲ್ಸ್ ಕಾಣ್ತಾ ಇರಲಿಲ್ಲ ಟೂಲ್ಸ್ ಹೋದೆ ನಾನು ಕಂಟ್ರೋಲ್ ಟಿ ಅಲ್ಲ ಇಲ್ಲ ಅದೊಂದು ಡೈಲಾಗ್ ಬಾಕ್ಸ್ ಬಂದಿದೆ ಮಿಮಿ ಸ್ಟುಡಿಯೋ ಹೆಲ್ಪ್ ಅಂತ ಕಿರಣ್ ಇದ್ರು ಹೌದು ಅಲ್ಲೇ ಇದ್ದೀರಾ ಇಲ್ಲಿ ಹಾ ಅಲ್ಲ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದೀನಿ ನಾನು ಹುಡುಗ ಕ್ಲಾಸ್ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದೀನಿ ಬಟ್ ಏನು ಆಡಿಯೋ ಆಫ್ ಮಾಡ್ಲಿಕ್ಕೆ ಆಗ್ತಾ ಇಲ್ಲ ಆಯ್ತು ನೀವು ತುಂಬಾ ಲೇಟ್ ಆಗುತ್ತಾ ಆಯ್ತು ಓಕೆ ಪ್ರಾಬ್ಲಮ್ Am I audible? Hello?
Yes, sir.
Yes, sir.
Hello, sir. Ready? Hello, sir. Hello. Sir, ಹೇಳಿ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಇದ್ದೀನಿ ಜಬ್ರಿ ಬರಲ್ಲ ಆಯ್ತು ಸರಿ ನಂಗದೇ ಹೋಗೋರಿಲ್ಲ ಅದಕ್ಕೆ ಸರಿ just a minute, the system is hang. That time is ಅಲ್ಲ ನನ್ಗನ್ಸುತ್ತೆ ಪೆನ್ ಚಾರ್ಜ್ ಇದೆಯಾ? ಅದು ಈಗೆಲ್ಲ ಬಾಕ್ಸ್ ಬಂದು ನಿಂತಿದೆ.
ಅದೇನು ಗೊತ್ತಾ,
ಏನಾಗ್ತಿಲ್ಲ.
ಇದರಲ್ಲಿ ಒಂದು ಪ್ರೆಸ್ ಮಾಡಿರಬೇಕು. ಇದೊಂದು ಬಟನ್ ಆಫ್ ಮಾಡಿ ಆನ್ ಮಾಡಬೇಕು. ಇದು USB ಫಸ್ಟ್ ಇದು ಬರುತ್ತೆ.
ಈಗ ಬಂತಲ್ಲ, ಹಾ ಸರಿ ಆಯ್ತು ಬಿಡಿ.
ಆದ್ಮೇಲೆ ಏನ್ ಮಾಡ್ಬೇಕು ಅಂದ್ರೆ, ಇಲ್ಲಿ ಪೆನ್ ಡಿಸ್ಪ್ಲೇ ಬರುತ್ತೆ, ಇಲ್ಲಿ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡಬೇಕು.
ನೀವು ಅಲ್ಲಿಂದ ಓಡ್ ಬಂದ್ರ?
ಇಲ್ಲಿ ಲಿಫ್ಟ್ ಆಯ್ತು, ಮುಂದೆ ಲಿಫ್ಟ್ ಅಲ್ಲಿ
ಲಿಫ್ಟ್ ಇತ್ತಲ್ಲ,
ಇದನ್ನು ಟಚ್ ಮಾಡಿತ್ತು ಅವರು. ಇದು ಎರಡು ಟಚ್ ಮಾಡ್ಕೊಂಡು ಅಂತ ಹೇಳಿದ್ದೆ. ಕಂಟ್ರೋಲ್ ಟಿ.
ಇದು ಟಚ್ ಮಾಡ್ಬೋದು, ಆಡ್ ಪೇಜ್
ಟಚ್ ಮಾಡ್ಬೋದು. ಈ ಕಡೆ ಟಚ್ ಮಾಡ್ಬೋದು. ಇದೆರಡು, ಇದು ಮತ್ತೆ ಇದು
ಅಲ್ಲ, ಆಡ್ ಪೇಜ್ ಇದೆ ಅಲ್ಲ,
ಸೆಕೆಂಡ್ ಒನ್ ನೋಡಿ, ನ್ಯೂ ಆಕ್ಟಿವಿಟಿ, ಕೊಲಾಬ್ರೇಟ್, ಇದೆರಡನ್ನು ಕರೆಕ್ಟ್ ಟಚ್ ಮಾಡ್ಬೋದು. ಬಂತಲ್ಲ ಕಂಟ್ರೋಲ್ ಟಿ.
ಸರಿ ಸರಿ, ಕಂಟ್ರೋಲ್ ಟಿ ಮಾಡಿದ್ರೆ ಬರುತ್ತಲ್ಲ.
ಎರಡು ಸಲ ಪ್ರೆಸ್ ಮಾಡಿ.
ಸರಿ ಸರಿ, ಥ್ಯಾಂಕ್ಸ್ ನಿತೀಶ್, ಓಡಿಸಿದಾಗ ಆಯ್ತು. ಸರಿ ಸರಿ. ಹಲೋ, ಆಮ್ ಆಡಿಬಲ್? Screen is visible, right?
Yes, sir.
ಇಲ್ಲಿ ನೋಡಿ ನಿತೀಶ್, ಇದು ಮತ್ತೆ ಪುನಃ ಹಾಗೆ ಆಯ್ತು. ಇದೊಂದು ಡೈಲಾಗ್ ಬಾಕ್ಸ್ ಓಪನ್ ಆಗಿದೆ, ಮಿಮಿ ಸ್ಟುಡಿಯೋ ಹೆಲ್ಪ್ ಅಂತ. ಅದು ಕ್ಲೋಸ್ ಮಾಡ್ಲಿಕ್ಕೆ ಹೋದೆ ನಾನು. ನೋಡಿ, ಆಗುದಿಲ್ಲ, ಕ್ಲೋಸ್ ಆಗುದಿಲ್ಲ, ಪುನಃ ಹಾಗೆ ಆಯ್ತು.
ಯಾವುದಕ್ಕೆ ಅದು ಬಂದದ್ದು ಹೇಗೆ?
ಅದು ಇಲ್ಲಿತ್ತು, ನಾನು ಇದು ಮತ್ತೆ ಕ್ಲೋಸ್ ಮಾಡುವ ಅಂತ ಅನ್ಕೊಂಡೆ. ಹೌದು, ಈಗ ಸರಿ ಆಯ್ತು. ಸರಿ, ಇವತ್ತು ಓಕೆ, ಸರಿ ಸರಿ. Okay, so step 2. Last class we have drawn this figure with actual scale. Actually, in this problem it is a single slider crank mechanism. The crank is a second link, that is AB, and BC is a connecting rod, link number 3. We have a piston, that is link number 4, and we have a force P is equal to 2000 Newton along the horizontal direction acting on a piston. And we have one more force, that is Q, is acting on connecting rod and at an angle of 60 degrees to the connecting rod. So the force is 800 Newton, right? Now we need to find out the what we have to find in this. We have to find out the torque required, right? Is it correct? Torque required T. Okay, so after this we need to find out the torque. First we need to analyze all the forces in this system. Let us go to the free body diagram. Step 2. Step 2, free body diagram. ಏನ್ ಮಾರಿದಿ ಅಂತ ಪ್ರಾಬ್ಲಮ್ ಅಂತ ಗೊತ್ತಾಗ್ತಿಲ್ಲ. Okay, step 2. Just a minute. ಏನ್ ಟ್ರಬಲ್ ಕೊಡೋಕ್ ಮಾರಿದು ಇವತ್ತು ಈ ತರ ಆಗಿದೆ. ಹಿತೇಶ್ರೇ, ಅದು ಪೆನ್ ಪಾಯಿಂಟ್ ಕರೆಕ್ಟ್ ಆಗಿ ಬರೀತಿಲ್ಲಲ್ಲ. ಹೌದು, ಹೇಗೆ ಮಾಡ್ಬೇಕದು? ಐಕಾನ್ ಅಲ್ಲಿ ಟೂಲ್ ಟಚ್ ಸೇಫ್ಟಿ. ಅದು ಇಲ್ಲಿ ನೋಡಿ ಹೀಗೆ ಬರ್ತಾ ಇದೆ. ಇಲ್ಲಿ ನೋಡಿ ಸ್ಟೆಪ್ 2 ಇಲ್ಲಿ ನೋಡಿ ಬರೀತಿಲ್ಲ ಅಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ
ಪೆನ್ ಡಿಸ್ಪ್ಲೇ ನೋಡಿ ಇದು ಇದು ಹೋಯ್ತು. ಇಲ್ಲಿ ಬರುತ್ತೆ ಐಕಾನ್ ಇವಾಗ ಇದು ಇಲ್ಲಿ ಕ್ಯಾಲಿಬ್ರೇಷನ್.
ಆಗುತ್ತಾ?
ನೋಡಿ
ಹೀಗಾಗುತ್ತೆ.
ಇದಾಗೊಂದು ಎರಡು ಬಂದಿದೆ ಮೆಸೇಜ್. ಅದು ನಾವು ಮಾಡಿ ಮಾಡಬೇಕಿತ್ತು.
ಓಕೆ,
ಮೊದಲು ಅದರದ್ದೇ ಇರಬೇಕು, ಕಾಲ್ ಪೆಟ್ಟಿದ್ದು ಮೆಸೇಜ್ ಅದು.
ಹೌದು. ಓಕೆ, ಸೊ ಸ್ಟೆಪ್ 2. Step 2, free body diagram. Now we need to draw the free body diagram for all the links. There are 4 links here. Link number 1 is a fixed link, and link number 2 is a crank. Link number 3 is a connecting rod, and link number 4 is the piston, right? Now these links you can draw with actual scale, or you can draw with I think it's better to draw with actual scale, because you need to find out the distance also, perpendicular distance. Okay, so I'm going to draw with actual scale. Please look at this. In the previous figure, what the scale we have taken, 1 centimeter is equal to 100 millimeter, right? And the first link is a crank, link number 2, 45 degree, and the length is 100 millimeter. I think it is AB is 300 means 3 centimeter. Okay, write down. First you take this is a 0 degree line, and I'll take 3 centimeter at 45 degree angle. Please take 3 centimeter length at 45 degree angle. So this is what the 45 degree, and this is A, B. We have link number 2 here. Okay, link number 2, 45 degree, correct? So it's better to draw 45 degree exactly. .45 degree, link number 2, and B. Okay, so this is the first link, and we need to show the forces on this link, because see here we have point A and point B. There are forces, but let us consider the force is acting on this point B. Okay, point A is a force acting by the link number 1. So that I don't know the direction as well as magnitude. So I'll show like this. This is what the force. This is F12 due to link number 1 or link number 2. Okay, F12. But I don't know the direction. I don't know the magnitude. Next is you cannot draw the force. See, this is the link connection between link number B, or the point B is a link number 3 and 2 is connected together. It is a common point of link number 2 and 3. But I cannot show the force like this. This is F32. No, it is not like that, because we have extra force here. In the previous problem, what we have done, look at this. See, this force, the force due to link number 3 or link number 2, we have shown it like this. See, this is 3-2. It is along the direction of link 3, but here it is not like this, because there is no force here on the in between the link number 3. So that's why I've shown this force F32 directly along the direction of link number 3. But here it cannot do like that because we have extra force Q on this link number 3. That's why the force due to link number 3 on link number 2 will not be the same as the direction of link number 3. It will be somewhere away. So I'll show this force. See, this is what the force. I don't know the direction, but I don't know the magnitude. F32. F32. That is the force due to link number 3 on link number 2. Why I have shown the zigzag line? Because I don't know the direction. I don't know the magnitude. Why I don't know the direction? Because there is an extra force acting on link number 3. That's why I cannot identify the direction of F32 or F23. So it is an unknown direction. That is a link number 2. And we have one more torque, that is T. I don't know the direction of T, right? That is T2. T2. Right? After that, that is the first link number 3. Link number 2. Link number 3, you just go back to the previous slide. Here, what is the angle? You just measure it. Please, can anyone tell me the angle? This angle? Can anyone measure the angle? That angle is very, very important.
20 degree.
Yes,
20.
20, exactly. 20, exactly.
Yes.
Okay. 20. I will take 20-degree angle. So you just take a reference line anywhere. Okay. I'll take a reference line somewhere here. You can take anywhere, no problem. I'll take a reference line somewhere here. Okay. Okay. So after taking the reference line, please concentrate on this problem. Otherwise, it will be difficult. Somewhat complicated one. Okay. I'll mark a point somewhere here and I will take 20-degree line here, 20 degree. So this is 20 degree, correct? Someone told it is 20 degree. So 20 degree. So I will take a 20-degree angle. Okay. So this is what the 20-degree line. And what is the length of this line? Please take actual scale. What is the length of this BC? BC 600. 600 means 6 centimeter. Please take 6 centimeter only. But in the previous problem, we have taken a random length, right? But you better to take 6 centimeter actual length. Yeah, 6 centimeter. I will take as B, this as C. Okay, and what is the link? Link number 3. Link number 3. Okay. Now this is 20 degree. 20 degree. Next is what next? Now we need to show the forces, right? We have already known the force, that is Q at a distance of BD. BD distance is 200, means 2 centimeter. Mark 2 centimeter from B. 2 centimeter will be somewhere here. This point is Q. Correct? Sorry, D, right? D. This point is D. And I have a force Q at an angle of 60 degree. You can take any length, no problem, but angle should be 60. Okay. This is Q is 800 Newton. 800 Newton. Okay. One force is marked. Another force. See, this is a common point, right? Point B here. All of you copied? Copied? Hello?
Yes, sir.
Okay. You marked the Q also, right? Force Q. Okay. Point B somewhere here, right? And I have a force. See, one force is acting here, F32. It is the force. See the link number 2. Force by link number 3 on link number 2. Here, the same amount of force will be acting on the point B. If you consider link number 3, I don't know the direction, I don't know the magnitude, okay? So I will show it as zigzag line. So this is indicates this is F23, F23. The same point, if you mark F32, on the same point, other link will have F32, or sorry, F23. Okay, so this is the force F23. F23 is also, we don't know the magnitude, we don't know the direction. Okay, zigzag line. Next, you come back to the point, other point C. If there is no Q, then C would be in the direction of link number 3, right? Like this. But it is not like that, because we have extra force here. That's why here also we have a force, unknown force, that is F. Which point is connected to the link? Which link is connected to the point C? Link number 4, right? You see the previous slide. Link number 4 is connected to C. So what is the force acting on link number 3? That is F4-3. Force by link number 4 on link number 3. I don't know the direction, I don't know the magnitude. So zigzag line. It is similar to the previous problem, but due to Q, the direction of F23 and F43 will be unknown. Copied? Hello? Hello? Finished?
Yes, sir.
Okay. Any doubt? Any doubt? What else is remaining now? Piston is remaining, right? Fourth one. So I will draw the piston now. Piston, fourth link. Yeah, this is the piston. Correct? Link number 4, and the point C is here, and this is link number 4. Okay. Now, what are all the forces acting on this link? So one is P, applied force, horizontal force. P, what is the P value? P value is 2000, right? 2000 Newton. One. Another force, here you see the link number 3, we have F43. The same amount of force, opposite force acting on link number 4. That is also unknown direction. I will show it as unknown direction. Look at this. Yeah, unknown. You can show anywhere, no problem, okay, because it is unknown direction. So F34 due to link number 3 on 4. Okay. Next, one more force is the downward force, opposite force or upward force. Look at this. We have a force, we will be having one more force in the upward direction, right? Exactly vertical. So that I'll show it in the pre-body diagram. See, this will be known direction. This is the direction is known. What is the force? This is F due to link number 1 on link number 4, F14. F14. Correct? F14. What is the indication of F14? Force by link number 1 on 4. So this is what the pre-body diagram of link number 2, link number 3, and link number 4. I have shown all the forces and their directions. Right? Okay. Here, look at this. We know the direction of Q, direction of P, and direction of 1, 4. We know the magnitude of Q and P, but all other directions and magnitudes are unknown. Right? We need to start solving the problem. Unknown things we need to find out. Because what is the target? You need to find out the value of T2. To find out the value of T2, we need to find out the value of F32 and F12. If you know the value of F32 and F12, you can find out the value of T2. So that is the target. Correct? Okay. Because link number 2 is a two force member with a single torque. What is the condition for two force member? Both the forces will be equal and opposite. Equal and opposite and parallel. So F32 is equal to F12. But we need to find out the value of F32. How do you find out the value of F32? By finding the value of F23. If you know the value of F23, it is equal to F32. Correct? F32. Now, how to find out F32? That is the question. In the previous problem, F23 is equal to F43. But here it is not like that. Correct? Because we have extra force Q. All of you copied? All of you copied?
Yes, sir.
Shall we go to the next slide? Next step. If you have not copied, you can copy it. Do it neatly with actual scale. Don't do the freehand sketch. If you are doing the freehand sketch, please leave the meeting. No need to attend my class. I told you in the beginning only, very first class of this module. If you are drawing freehand sketch, no need to attend my class. You can refer some textbook. You will have a solution. You can refer it and can write the exam. No need to attend my class. You take your own time, but do it with actual scale. Okay. So free body diagram is over. This problem, if you draw the free body diagram correctly, then the solution will be easy. Otherwise, it will be difficult. Okay. Okay. See, here we have three different links. One is link number 2. Link number 2, because all are unknown. T2 is unknown, F32 is unknown, F12 is also unknown. You cannot select this link to solve the problem. Next step, right? You cannot take this link number 2 for the next step. You forget it. Here we have link number 3. In link number 3, two forces are unknown, this and this, and one is known, that is Q. Q is known, right? One is known. And see the direction also. Here we have F43, unknown direction, unknown magnitude, right? Unknown direction, unknown magnitude. Correct? Unknown, unknown. F23, unknown magnitude, unknown direction. You see, correct? Both are unknown. Here, both are known. Which one? Q. Q, both are known. Look at this. Known. So, is it possible to draw the force polygon in this case? No, because maximum thing is unknown. You cannot take this link number 3. So here, this is very, very important step. For the next step, which link you are going to consider, that you need to select it properly. You come back to the link number 4. Here, link number 4, we have, see the link number 4. This is unknown direction, unknown magnitude. Correct? Here we have known direction, known magnitude. Here we know the direction, but we don't know the magnitude. Correct? We don't know the magnitude. Is it possible to draw the force polygon? You check it. Is it possible to draw the force polygon for this case? See, look at this. Let us start drawing the force polygon for this one. Okay, we'll check it. Okay, roughly. You know the value of P. P, I'll take 2000 Newton. Okay, P. Next, 1,4. I don't know the magnitude, but I know the direction, vertical. So draw it. Now, how to draw this F34? We don't have any point, right? And we don't have the direction. You can draw like this, or like this, whatever it may be. I don't know the direction. So you cannot draw the force polygon for this one, fourth one. So then how to solve the problem? Second is also not possible. Sorry, third link is also not possible. Fourth is also not possible. Second is also not possible. So which one to be taken for the next step? That is the question. That is the question. So for this case, you just imagine, I don't know the direction of F43, F23. I will take this link, okay, link number 3. In this case, we need to select link number 3. Select link number 3. I'll tell you how to draw this. Step 3. Step 3. Finding unknowns. finding unknowns. Consider link 3. Which link I'm going to consider? I'll consider link number 3. Link number 3. Why I am going to consider link number 3, I'll tell you later. Okay. So I know I cannot select link number 2, link number 3, link number 4 because I cannot solve this problem by drawing a force polygon because we have a lot of unknowns, right? Okay. That's why I'm going to consider link number 3. Okay. Link number 3. What I'm going to do is in the link number 3, see here, link number 3, we have Q, we have F23, and we have F43. F34 and F43 and F23 is unknown, right? Unknown. What I'm going to take is, I am going to take a moment about any arbitrary point. Any arbitrary point, there are infinite number of points on this link number 3, right? But I have to select a point where the unknown force is there. Here, which point is having unknown force? Point B. This is the point B, right? Yeah. Point B and point C. Point B, we have F23 is unknown, and point C also we have unknown force, that is F43. Either you can take B or C. About B or C, you take a moment. We can solve the problem. Okay. I'll take the moment about point B. If you take the moment about point B, so I can take the moment of Q into perpendicular distance. I'll measure the perpendicular distance like this. Okay, H. So this moment into this moment F32, but I don't know the F43. I don't know the direction of F43. If you know the direction, you can take the perpendicular distance, but I don't know the direction of F43. For that, what I'm going to do is, I will split this F43 into 2 components. How many components? 2 components. One is tangential component, tangential. Another one is normal component. Normal component. I will split this F43 into tangential component and normal component. Okay? Tangential component and normal component. Why? Because I cannot take the moment about point B because I have selected point B as a fixed point. So moment about B for the force F23 will be 0, right? Because the perpendicular distance is 0. But here, to take the moment of the force F43, I know that I should know the direction of F43, but I don't know the direction of F43. That's why I'm going to split into tangential and normal component. Okay, write down next step. Consider link number 3. Consider link number 3. Below that, write down. Take moment about point B. Point B or C. Okay, no problem. It's left to you, or C. Okay, but I'm going to take consider as B. Okay. With respect to B, I'm going to take a moment at point B. Okay, take a moment about point B. Okay, to take a moment, write down, to take moment for F43. Which force? F43, right? F43, we should know the direction. Should know the direction of F43, which is unknown, which is having unknown direction. Unknown direction. This text no need to write. Okay, it is for your reference. I'm giving known direction. Therefore, split F43 into F43 tangential and F43 normal. What is this T indicates? It is a tangential component. What is the N indicates? It is a normal component. Okay, into tangential and normal components. Okay, tangential and normal component. All of you copied? Copied?
Yes, sir.
Any doubt? Okay, any doubt? See the step, third step, very, very important, finding unknowns. First, we need to consider the link number 3. In the link number 3, I have to select any point. There are 2 points of unknown force. One is B or C. You cannot select D, okay? Because known force is there. Intentionally, you're going to make it 0. No use. So that's why you need to make unknown force to 0. That's why I have to select B or C. I'm selecting B as a reference point, arbitrary point. So I need to take a moment about point B. D you can take, but C I have unknown force both in direction as well as magnitude. That's why I need to split into 2 components, tangential and normal. Okay, so I'll draw the figure here. Look at this. So link number 3 with actual scale. Okay, with actual scale, I'll draw it here. Look at this. This is a point. 20 degree, correct? 20 degrees, 6 centimeter length. This is 2 centimeter D. Correct? So this is B, C. Okay, so we have unknown force zigzag. This is F, 23, correct Allah? F23. ಇನ್ನೊಂದು ಯಾವ್ದಿದೆ? So we have one more force that is 60 degree, at 60 degree, correct? Draw at exactly 60 degree. That is Q, 800 Newton. Next, you come to C, point C. What I'm going to do is, I'm going to split this F43 into 2 components, tangential and normal. First, I'm going to take a tangential, okay? Tangential is nothing but the force which is tangential. Which is tangential. Tangential means along the tangential direction. Tangential means it is perpendicular to what? Perpendicular to the link number 3. This is the link number 3. So perpendicular to link number 3. I am going to show it here. Look at this. This is perpendicular to link number 3. I have less space. So that's why this should be perpendicular, exactly perpendicular. This is F43 tangential T, F43T. Please draw a little bit larger figure. I have less space here. That's why I have shown like this. Why it is upward? Because see, Q is acting in the downward direction. Automatically, this force will be the upward. It is understood. Right? It is understood. So, if the force Q is acting in this downward direction, you cannot draw this in this direction. Is it possible? No. Because the system will not be in equilibrium. So if you want to make it in equilibrium, so it should be in the upward direction. So that's why I've shown it in the upward direction, not in the downward direction. So the tangential. Now, what is the normal component? A bit okay, complicated one. So I'll show it. Okay, I'll redraw it. I need to have enough space for this one. I'll show it. Okay. So this is C. First, we need to perpendicular. Okay, exactly perpendicular. This is perpendicular. Perpendicular. This is F. What is this? F43 tangential. F43 tangential. 43 tangential. Now, where is the normal component? The normal component is always along the direction of the link. Always along the direction of the link. But I don't know whether it is away from the link or towards the link. I don't know the direction. So I'll leave it as it is. I'm not showing the direction. Okay. So this is F43 normal. Normal along the direction of the link, along the direction of the link. So I am going to split this force. Which force? F43 into two components. One is a tangential component, another one is normal component. I know the direction of tangential component, but I don't know the direction of normal component. Why tangential component is known? Because Q is downward, automatically tangential component will be the upward direction. But normal component, I don't know whether it is away from the link or towards the link. I don't know because I don't know the direction of F23. Any doubt in this case? Any doubt? Hello? Any doubt? ಮಾತಾಡ್ರೋ
No, sir.
ಎಲ್ಲ ಮಲ್ಕೊಂಡಿದ್ದೀರೇನಾ? ಮೋಹಿತ್, ಮಿಸ್ಟರ್ ಮೋಹಿತ್.
Yes, sir.
ಓಕೆ, ವೆರಿ ಗುಡ್. ಏನೋ ಡೌಟ್ ಇದೆಯಾ ಮೋಹಿತ್?
ಇಲ್ಲ ಸರ್.
ಸೈಬನ್ ಅಸ್ಪಾಕ್,
Yes, sir.
ಎನಿ ಡೌಟ್?
No, sir. No doubt.
ಕತೆ ಹೇಳ್ದಂಗೆ ಹೇಳ್ತಾ ಇದೀನಿ, ಇನ್ನೂ ಡೌಟ್ ಅಂದ್ರೆ ಕಷ್ಟ. ಇದಕ್ಕೂ ಸ್ಲೋ ಮಾಡ್ಲಿಕ್ಕೆ ಆಗಲ್ಲ. ನೋ ಡೌಟ್.
ಇಲ್ಲ sir. Doubt ಇಲ್ಲ. No doubt, sir.
ವೆರಿ ಗುಡ್ ಸೈಬನ್. ನಿತಿನ್ ನಿತಿನ ಮಲಗಿದ್ದೇನಾ? ನಿತಿನ್ ನರೋನಾ? Nitin, shall I remove you from the class? ಕರೆದ್ರೆ ಮಾತಾಡ್ತಿದ್ರೆ ನಾನು ಅಬ್ಸೆಂಟ್ ಹಾಕೊಂಡು ಹೋಗ್ತೀನಿ, ನನಗೇನು ತೊಂದರೆ ಇಲ್ಲ. ಓಯ್ ನಿತಿನ್, ಇಲ್ಲ. ಮೊಹಮ್ಮದ್ ಗೌಸ್?
Yes, sir.
ವೆರಿ ಗುಡ್. ಗೊತ್ತಾಯ್ತೇನಾ ಗೌಸ್?
Yes, sir.
Okay. Okay, shall we proceed? See, now you can take the moment, right? You can take the moment about point B. How? Point B with respect to point P, if you take the moment about Q, okay, take a moment about Q. Write down. Take below this. Take moment about Q. Sorry, B, Allah? B. Okay. So what is the moment? So moment about the point B, if you take F23, perpendicular distance will be 0. Okay, that is cancelled. The next one, Q into perpendicular distance. How do you find out the perpendicular distance? I am going to draw the parallel line to Q. Look at this. I'm going to draw the parallel line to Q. Parallel to Q, just draw a parallel line to Q. These two lines should be parallel. Okay? Through point B. We'll have a perpendicular line. Just draw a perpendicular line. ಇದಕ್ಕೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಇರಬೇಕು, ಲೈನ್ ಡ್ರಾ ಮಾಡಿ. ಸೊ ದಟ್ ಈಸ್ H. So this is H. What is this? Magnitude, direction. Clockwise or counterclockwise? It is a clockwise, positive. Next, F43T. Clockwise or counterclockwise? You are standing here. Clockwise or counterclockwise? Please find out the H value. Can anyone tell me the answer for H? So minus counterclockwise F43 tangential into distance AB. AB. Is there any force? No. F43 normal is 0 because it is passing through point B, is equal to 0. Q is 800 into, what is the value of H? Exact actual dimension, what you are going to get? Right answer. Ishwanto?
1.7
1.7 centimeter alla? Into scale minus F43 ನನಗೆ ಗೊತ್ತಿಲ್ಲ. So T into AB. What is the length of AB? ಕೊಟ್ಟಿದ್ದ ನೋಡಿ. Length of AB ಎಷ್ಟು ತಗೊಂಡಿದ್ದೀರಿ? ಲೆಂತ್ 6 ಅಲ್ಲ? 6 into scale. ಏನಿದೆ ಅದನ್ನ ಬರ್ಕೊಂಡು ಸ್ಕೇಲ್ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೊಳ್ಳಿ, ಬಿಕಾಸ್ ಇಟ್ ವಿಲ್ ಗೆಟ್ ಕನ್ಫ್ಯೂಸ್ಡ್. ಸ್ಕೇಲ್ ಬಿಡಕ್ ಹೋಗ್ಬೇಡಿ. ಸೊ 800 into 1.7 into scale is ಎಷ್ಟು ಸ್ಕೇಲ್? 100 millimeter. 1 centimeter ಅಂದ್ರೆ 100 millimeter, right? 100 by 1 minus F43 unknown, correct ಅಲ್ಲ? into 6 into 100 by scale 100 by 1, correct ಅಲ್ಲ? is equal to 0. Now tell me the answer for F43T. Answer for F43T. Can anyone tell me the answer for F43T? F43T. Can anyone tell me the answer? Hello?
Sir, it's AB or BC?
Sorry, BC adu ಆಯ್ತಾ? BC ಆಯ್ತಾ? Length BC. Please change it. BC, correct? Very good. Who is this? BC 6 centimeter alva? Who is this? Loyal, very good. Okay, now tell me the answer for F43. Loyal, ready? Answer?
Wait.
Okay. ಎಷ್ಟು? 226. Very good answer. 226, correct ಅಲ್ಲ?
0.6.
F43 tangential is equal to 2. ಎಷ್ಟು ಬಂದಿದೆ?
226.6.
0.6 Newton. Very good answer. ಅಂದ್ರೆ ನಮ್ಮ ಹುಡುಗರು ಕರೆಕ್ಟ್ ಸ್ಕೇಲ್ ಪ್ರಕಾರ ಮಾಡ್ತಿದಾರಂತ ಆಯ್ತು ಅಲ್ವಾ? ಈಗ ನೋಡಿ F43 ಇದು ಡೈರೆಕ್ಷನ್ ಗೊತ್ತು, ಐ ನೋ ದ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆಲ್ಸೋ, ಕರೆಕ್ಟ್ ಅಲ್ಲ? ಈಗ ಪ್ರಾಬ್ಲಮ್ ಈಸಿಯಾಗಿ ಸಾಲ್ವ್ ಮಾಡ್ಕೊಂಡು ಹೋಗ್ಬೋದು. ಐ ಹ್ಯಾವ್ ಒನ್ ಕಂಪೋನೆಂಟ್ ವಿತ್ ಅ ನೋನ್ ಡೈರೆಕ್ಷನ್ ವಿತ್ ನೋನ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್, ಕರೆಕ್ಟ್? Okay, F43T, if you know this force, you cannot find out F43 normal or F23 because it will be complicated, because I don't know the direction of F23 and F43 magnitude, right? I know the direction of F43, but I don't know the magnitude of F43. You leave it as it is. We'll go to the next link number 4. All of you copied? All of you copied? All of you copied? Shall we go to the next slide?
Yes, sir.
Okay, very good. Next slide. Consider this is step 2, okay? In the step 3, we have step 1 is here. Step 2, consider link number 4. Link number 4 ಏನida? It is a piston, right? See, piston. I will change the small. I'll change the indication of force. A very small change I can do it here because F43 is there now. It is a force F34 is a force of F43. Both are same, but I don't know the magnitude. I don't know the direction, right? F43 is acting on link number 3. F34 is acting on link number 4. That's all. Okay, no other change. Only the direction is different, but the magnitude is same. I'm going to take that force. Okay, you just come to the piston here. This one. Here I have three forces. You just forget about this F34. Okay, show other forces. Okay, I will show this forces. See, this point is C. One is upward force that I have shown in the free body diagram. Correct, F43. Sorry, F14. And P is known, that is horizontal. Not exactly horizontal, okay, with a scale. P 2000 Newton. I have to show F34. F34 is equal to F43. But what I have done in the previous step, I have splitted this F43 into tangential and normal component. So I have to do the same thing here also in the fourth link. Also, what I have to do, I have to split F34 into tangential and normal component. You see the previous slide. Here we have F43 tangential. It is upward, correct? It is upward. But here it is downward. So downward means, look at this tangential component. Normal component is always along the direction of. So this is what the horizontal line, right? You just draw the horizontal line. See, normal component. Where is the normal component? Along the direction of the link number 3. So here also in the fourth link, along the direction of the link number 3. Along the direction of the link number 3 is nothing but this is 20 degree, correct? Draw 20 degree line. 20 degree line. So this force, which force? This force, I don't know the direction, okay? I don't know the direction, but I know the I know the direction, but I don't know the magnitude. So this is what the direction. But I don't know exactly whether it is upward or downward. Just leave it. This is F34, not F43. The previous case we have taken F43. But here it is acting on link number 4. That's why it is link number F34. Normal. This is normal, right? This direction is normal. Here also it is normal. Same direction. Now, where is the tangential? See, tangential component is perpendicular to normal, right? But it is upward. In this case, it is downward. Downward means like this. This is F34 tangential. Why it is downward? Because it is perpendicular to F normal. What I'm going to do is I'm going to take a piston. I'll show F43 in the F14 in the upward, P in the horizontal direction. Next, I'm going to take a horizontal line. Then I'll take a 20 degree line because it is the indication of link number 3. Then I'll take F3 for normal along the direction of 20 degree line. Then I'll take one more force that is perpendicular to normal, that is F34 tangential. Why it is tangential is downward? Because it is opposite to what? F43 tangential. Opposite to F43 tangential. Why? Because it is reverse, right? Because in the previous problem, what I'm going to do is link number 3, link number 4 is like this. Previous problem, you just check it. So if the force acting like this, then in this fourth link it will be opposite, correct? So same thing I'm going to do it. Here it is upward, I'll take this downward in this case. But normal force, I don't know the direction, you just leave it. Any doubt in this case? I have split it F34 into tangential and normal. F34. By referring the previous link, link number 3. Link number 3, we have shown all F1, F3, sorry, F43 normal, F43 tangential. Same thing we have to copy, but direction is different. That's all. Any doubt in this problem? Or in this case? Hello? Any doubt in this case? ಯಾರಾದ್ರೂ ಮಾತಾಡ್ರಾ?
No, sir.
Any doubt? ಇದೆಯಾ? ಯಾರೋ ಮಾತಾಡ್ತಿದ್ದಾರೆ, don't hesitate. If you have any doubt, you can ask. I can clear it. ಋತ್ವಿಕ್, any doubt ಇದೆಯಾ?
No, sir.
No. Shall we proceed? ನಾನು ಏನ್ ಮಾಡಿದೆ ಲಿಂಕ್ ನಂಬರ್ 4 ಅಲ್ಲಿ ಏನ್ ಲಿಂಕ್ ನಂಬರ್ 3 ಅಲ್ಲಿ ತಗೊಂಡಿದ್ದ ಈ F43 ನ ಅದನ್ನೇ ಸ್ಪ್ಲಿಟ್ ಮಾಡಿದೀನಿ. F34 ಅಂತ ಸ್ಪ್ಲಿಟ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀನಿ. ನಾರ್ಮಲ್ ಅಂಡ್ ಟ್ಯಾಂಜೆನ್ಷಿಯಲ್. ಡೈರೆಕ್ಷನ್ ಅಪೋಸಿಟ್. ಯಾವ್ದಕ್ಕೆ ಡೈರೆಕ್ಷನ್ ಅಪೋಸಿಟ್? ನಾರ್ಮಲ್ ಐ ಡೋಂಟ್ ನೋ ದ ಡೈರೆಕ್ಷನ್. ಐ ಹ್ಯಾವ್ ಶೋನ್ ದ ಸೇಮ್ ಥಿಂಗ್. ಬಟ್ ಟ್ಯಾಂಜೆನ್ಷಿಯಲ್ ಇಲ್ಲಿ ಅಪ್ವರ್ಡ್ ಇದೆ ಅಲ್ವಾ? ಟುವರ್ಡ್ಸ್ ಅಪ್ವರ್ಡ್ ಡೈರೆಕ್ಷನ್. ಹಿಯರ್ ಐ ಹ್ಯಾವ್ ಟು ಶೋ ಇಟ್ ಇನ್ ದ ಡೌನ್ವರ್ಡ್ ಡೈರೆಕ್ಷನ್. ದಟ್ಸ್ ಆಲ್. ಕರೆಕ್ಟ್ ಅಲ್ಲ? ಇಲ್ಲಿ ನೋಡಿ, I know the direction of F43, so F34 tangential, magnitude is also known. ಇಲ್ಲಿ magnitude find ಮಾಡಿದೀವಿ 226.6. Here also I know the direction, magnitude. I know the direction but I don't know the magnitude. Correct ಅಲ್ಲ? ಇಲ್ಲಿ I know the direction but I know the magnitude. Is it possible to draw this in a force polygon? Yes, it is possible. Because two unknowns, 1, 2, 3, 4, 5, 6 are knowns. Correct? You can draw the force polygon. Go to the force polygon now. Draw the force polygon. Force polygon. Take scale. Scale is equal to 500 Newton. Because 2000 Newton ಇದೆ, ನಾನು ತಗೊಳ್ತೀನಿ 500 Newton is equal to 1 centimeter ಅಂತ ತಗೊಳ್ತೀನಿ. ನೀವು ಹಾಗೆ ತಗೊಳ್ಳಿ, ಬೇಕಾದ್ರೆ 500 Newton is equal to 2 centimeter ಅಂತ ತಗೊಂಡ್ರು ಓಕೆ, ನೋ ಪ್ರಾಬ್ಲಮ್. 250 Newton is equal to 1 centimeter ಅಂತ ತಗೊಂಡ್ರು ಓಕೆ. 250 ಅಂತ ಅಂದ್ರೆ ಎಷ್ಟಾಗುತ್ತೆ? 8 centimeter ಆಗುತ್ತೆ. 8 centimeters ಆಗುತ್ತೆ. ಇಟ್ಸ್ ಲೆಫ್ಟ್ ಟು ಯು. ಓಕೆ, ಫಸ್ಟ್ ಪಿ ಎಷ್ಟಿದೆ? ಪಿ ಎಷ್ಟಿದೆ? 2000 ಅಲ್ಲ? 2000 ಅಂತಂದ್ರೆ 4 ಸೆಂಟಿಮೀಟರ್. Horizontal line, exactly horizontal. Okay, O A 2000. Correct ಅಲ್ಲ? ನೆಕ್ಸ್ಟ್ ಬಂದು F34 ಯಾವ್ದು ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಮತ್ತೆ ಡೈರೆಕ್ಷನ್ ನೋನ್ ಅಂತ ನೋಡ್ಕೊಳ್ಳಿ. F34 is also known direction, magnitude, downward. What is the length? 226.6 centimeter. Sorry, 6 Newton. ಎಷ್ಟಾಗುತ್ತದು? 500 ಅಂದ್ರೆ ಎಷ್ಟು ಸೆಂಟಿಮೀಟರ್ ಆಗುತ್ತಾ? 0.5 centimeters. 0.5 ಗಿಂತ ಕಡಿಮೆ ಆಗುತ್ತಲ್ಲ? 1/500 into 226.6 0.4532 ಇದೆ 0.45 centimeter. Angle ಎಷ್ಟು ನೋಡಿ, angle, how do you measure the angle? You just look at this, you just measure this angle. What is this angle? Please check it. Andre 20 plus 90, this is 90, correct? 20 plus 90 ಅಂತಂದ್ರೆ 110, 110 minus 180, 180 minus 110, 70 degree, correct ಅಲ್ಲ? 70 degree ಬರುತ್ತೆ. Takes 70 degree downward. ಹೇಗೆ? Roller scale is easy. You just hold the scale on this, just draw it. This is 70. So ಈಗ ನಾನು force show ಮಾಡ್ತೀನಿ ನೋಡಿ. I'll show the force. This is what the force. But cut the length. What is the length? 0.5 ಅಲ್ಲ? ಇದೆಲ್ಲ ಬರುತ್ತೆ. This is point B. Okay, point B, 0.5 ಅಲ್ಲ? This is, what is this? F34 tangential. Okay, what next? What next? Next, normal. Normal, I know the direction, 20 degree. ಈಗ ಒಂದು reference line draw ಮಾಡ್ಕೊಳ್ಳಿ ಈ ಪಾಯಿಂಟ್ ಇಂದ. Draw a reference line, okay? Reference line. See, I'll draw a reference line. I don't know whether it is visible or not. See, this is a reference line. 20 degree draw ಮಾಡಬೇಕು. 20 degree means, look at this, is 20 degree. ಅಲ್ಲ, perpendicular draw ಮಾಡಿದ್ರೆ ಆಯ್ತಲ್ವಾ? Correct. Perpendicular. Because normal is perpendicular to tangential, correct? So draw the perpendicular line. I don't know the length, but I know the direction, right? Perpendicular line. Draw the perpendicular line. Very simple. Just draw the perpendicular line. That's all. It's what the perpendicular line. Correct, Allah? So I don't know the direction. So this is F34 normal. Perpendicular line draw ಮಾಡಬೇಕು. So it is a very long line, okay? Just extend it. I don't know the magnitude, so just draw it or extend it. Okay, so F43 normal. I don't know the direction. Next, last force is F14. So force polygon must be closed. I have shown one force, that is P. P is over, F43 tangential is over, F43 normal is over. One more is remaining, that is F14. But I know the direction, exactly vertical. So if you draw the vertical line, it has to intersect point O, because force polygon must be closed. So again, we need to draw the vertical line like this through point O. Nodi, idu. So this will be the force. This is F14 upward, alba. So F14. So this point is B, this point is C. Copied? ಎಷ್ಟು ಮರ 1.5 ಗಂಟೆ ಆಯ್ತಲ್ಲ, ಈ ಪ್ರಾಬ್ಲಮ್ ಇನ್ನೂ ಮುಗ್ದಿಲ್ಲ. ಹನ್ನೆರಡು ಕಾಲಿಗೆ ಮುಗಿಸ್ತೀನಿ ನಾನು, ಮತ್ತೆ ಬದ್ದೆ ಬ್ರೇಕ್ ಕೊಡಲ್ಲ, ಆಯ್ತಾ? All of you copied this? 3 ಗಂಟೆ ತಗೊಳತ್ತಾಯ್ತಾ ನೀವು ಈ ತರ ಸ್ಲೋ ಮಾಡಿದ್ರೆ? ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಒಂದೇ ಪ್ರಾಬ್ಲಮ್ ಮಾಡ್ಬರ್ಬೇಕಾಗುತ್ತೆ. ಅಲ್ಲಿ ಬೇರೆ ಬ್ಯಾಲೆನ್ಸಿಂಗ್ ಆಫ್ ರೊಟೇಟಿಂಗ್ ಮಾಸಸ್ ಬೇರೆ ಇದೆ, ಅಲ್ಲೂ ಕೂಡ ಫಿಗರ್ ಇದೆ, ಇದು ಡ್ರಾಯಿಂಗ್. ಸೊ ಯು ನೀಡ್ ಟು ಪ್ರಾಕ್ಟೀಸ್ ಇಟ್, ಅದರ್ವೈಸ್ ಯು ಕೆನಾಟ್. ಫಿನಿಶ್ಡ್? ಯಾರು ಮಾತಾಡ್ತಿಲ್ಲ ಮಾರ. ಹಲೋ, ರಿತ್ವಿಕ್ ಶೆಟ್ಟಿ. ರಿತ್ವಿಕ್, ನಾಟ್ ಋತ್ವಿಕ್.
ಎಸ್ ಸರ್.
ಆಯ್ತಾ, ಫಿನಿಶ್ ಮಾಡಿದ್ಯಾ?
ಆಯ್ತು ಸರ್.
ರವಿನ್?
Yes, sir.
ಆಯ್ತಾ ರವಿನ್?
Yes, sir.
ಓಕೆ, ಶಲ್ ವಿ ಗೋ ಟು ದ ನೆಕ್ಸ್ಟ್ ಸ್ಟೆಪ್? ಈಗ ನೋಡಿ F43 ಮೆಜರ್ ಮಾಡಿ. ಫೈಂಡ್ ಔಟ್ ದ ಆನ್ಸರ್ ಫಾರ್ F43. Therefore, write down below this figure F14, not 43. F14 is equal to OC into scale. OC length ಯಾರಾದ್ರೂ ಹೇಳಿ? Can anyone tell me the answer for OC? ಹೇಳ್ರೋ. Four centimeter exactly. OC length 4 ಬರ್ತಿಲ್ವಲ್ಲ ಮರ ಯಶವಂತ? ಮಿಸ್ಟೇಕ್ ಮಾಡಿದೆ ನೋಡಿ, ಚೆಕ್ ಮಾಡೋ. 4 ಎಲ್ಲ ಬರುದಿಲ್ವಂತ, ಸ್ವಲ್ಪ ನೋಡಿ ಚೆಕ್ ಮಾಡಿ. ಎಷ್ಟು ಬಂತು? ಇನ್ನೊಬ್ರು ಆನ್ಸರ್ ಹೇಳಿ. OC length
2 sir.
2. ಅದೇನ್ 2 ಬಂತ ಮರ? ಕರೆಕ್ಟ್ ನೋಡಿ, ನಾನ್ ಮಾಡಿದ್ ರಾಂಗ್ ಇರ್ಬೋದು, ನಂದು ಫಿಗರ್ ಸೇಮ್ ಬರ್ಬೇಕಂತಿಲ್ಲ ನಿಮ್ದು, ಅಷ್ಟು ದೊಡ್ಡ ಬರುವುದಿಲ್ಲ ಮಾತ್ರ. ರವಿನ್ ಎಷ್ಟು ಬಂತು? ರವಿನ್ ಬಾಯ್
Yes, sir. 2.
ಎಷ್ಟು ಬಂತ ಆನ್ಸರ್? 2. ಇಲ್ಲಿ ನನಗೆ 2.3 ಬರ್ತಾ ಇದೆ. ಕರೆಕ್ಟ್ ಮಾಡ್ತಿಲ್ಲ ಮಾರ ನೀವು. ಎಷ್ಟು ಬಂತ ಮೋಹಿತ್? ಮೋಹಿತ್ ನಿತಿನ್ ಹಲೋ ನಿತಿನ್ Mohit is there? Tell me the answer. ಇಷ್ಟೆಲ್ಲ ಕರಿಬೇಕು ಮಾರ. ಎಷ್ಟು ಬಂತು? 2.1. ಓಕೆ ಆಯ್ತು. 2.1 ಇಂಟು ಸ್ಕೇಲ್ ಎಷ್ಟು ತಗೊಂಡಿದ್ವಿ? 500, ರೈಟ್? ಆನ್ಸರ್ ಪ್ಲೀಸ್ ಆನ್ಸರ್.
$1050.
1050 ನ್ಯೂಟನ್. F14 ಕರೆಕ್ಟ್ ಅಲ್ಲ? upward, correct? It is upward. Next, ಇನ್ನೊಂದಿದೆ ನೋಡಿ. So here we have to find out. See, F34 is in this line. F34 tangential is in this direction, right? Now, if you join C with A, look at this. I'll join C with A. CA. This line indicates. This line indicates. See, this is normal, okay, in this direction, because if this is in this direction, this is in this direction, this will be close, so that this will be in this direction. Normal will be in this direction. So F tangential, sorry, F34. This line indicates, the diagonal indicates F34. So F34 or F43 na? F34. So this is a tangential component, it's a normal component. If you draw the diagonal, it is a F34. Directly we can find out F34. Here, therefore, F34 is equal to, what is the length? AC into scale. Normal could have find ಮಾಡ್ಕೊಳ್ಬಹುದು, no problem, but normal is not at all used. Okay, directly we'll get a F34, right? F34 force. F34. Answer for F34. What is the direction? Direction will be like this. Direction mention very careful, because this direction is very important. If normal is like this, tangential is like this, then it will be in this direction. Okay. Now tell me the answer for, or the length of AC. AC length ಎಷ್ಟು ಬಂತ? AC, please, can anyone measure AC and tell me the answer?
$4.5.
4.5 centimeter into scale. Scale is 500 ala. Answer?
$2,250.
Yes. Right? It is downward. Direction is very important. See, how do you find out the direction? This is downward, like this, right? And this is in this direction, because to close the polygon, this is a what? Polygon with the four sides, right? This is in this direction, this is in this direction, this is upward. Automatically, this will be in this direction. If these two forces are in this direction and this direction, this will be automatically downward. So that is downward. You cannot show upward. So what we have done in the previous step, we have split this into tangential and normal component, alva? Adukoskara. Illi matte ನೀವು, you cannot say it is like this, because you need to make it closed polygon. It is not a polygon. It is, this force is split into two components. That's why. Okay. See, this is actually the polygon triangle. Intentionally, we have split it into two forces. That's why it is the polygon with the four sides. Finished? Hello, finished? Okay. Now we have the value of F34. You go to the previous slide. F34 is known. Which one? F34 is known. F34 is nothing but F43. F34 is nothing but F43. If you know the value of F43 direction is same as F34. Okay, direction and magnitude. If you know the value of F43, you can find out the value of F23 because the link number 3 will be a system with 3 force member. One is this, this, and this. So you know how to do the equilibrium for 3 force member, right? So I'll do it. Look at this. Step 3. Consider link 3. Link 3. We need to consider the link 3 again. Link 3. So F43 is equal to F34 is equal to, what is the answer for F34? 2250. Newton. What is the direction? Here it is upward. Why? Because in the fourth link it is downward in this direction, but in the third link it will be upward. Is it okay? Upward. Upward. Okay. Okay. Now you come back to the third link. Link number 3. Link number 3 ಏನಡುತ್ತಾ 20 degree ಅಲ್ವಾ ಲೈನ್. ಫ್ರೀ ಹ್ಯಾಂಡ್ ಸ್ಕೆಚ್ ಡ್ರಾ ಮಾಡ್ಬೋದು, ಬಟ್ ಫ್ರೀ ಹ್ಯಾಂಡ್ ಸ್ಕೆಚ್ ಡ್ರಾ ಮಾಡಿದ್ರೆ ನಿಮಗೆ ಡ್ರಾಯಿಂಗ್ ಕಷ್ಟ ಆಗುತ್ತೆ. ಸೊ this is link number 3. B, this point is C, this is 20 degree. Link, the length is 6 centimeter, right? 6 centimeter. This is C. We have a force F34. F3 force downward anta. So what is the angle here? You just measure the angle. Look at this. How to measure the angle? Just draw a horizontal line. Measure this angle. What is this angle? Check it. Theta. What is the theta? What is the answer for theta? ಎರಡು ಅವರ್ 3 ಅವರ್ ಅಲ್ಲಿ ತಗೊಂಡ್ರೆ ಹೆಂಗೋ ಮರ ಯಾವ ಪ್ರಾಬ್ಲಮ್ಗೆ ಟೀಟಾ ಹೇಳ್ರೋ. ಸಿಕ್ಕಾಬಡ ಸ್ಲೋ ಇದ್ರ ಮಾರ, ಯಾರು ಆನ್ಸರೇ ಮಾಡೋದಿಲ್ಲ. ಎಷ್ಟಿದೆ ಆನ್ಸರ್ ಟೀಟಾ? ಟೀಟಾ ಹೇಳ್ರೋ, ಯಾರಾದ್ರೂ ಒಬ್ರು ಹೇಳ್ರೋ ಮರ. ಮೆಜರ್ ಮಾಡಿ ಹೇಳ್ಲಿಕ್ಕೆ ಎಷ್ಟೊತ್ತದು? ಒಂದು ಲೈನ್ ಹಾರಿಜಾಂಟಲ್ ಲೈನ್ ಡ್ರಾ ಮಾಡಿ ಹೇಳಿದ್ರೆ ಆಯ್ತಪ್ಪ ಅದು ಆಂಗಲ್. Saiban, can you tell me the answer? Saiban.
Yes, sir. Doing, sir.
Manjunath R. Manjunath R. Manjunath is there? Jitesh? Jitesh? Jitesh, I'm audible? I'm audible, Jitesh? Okay, can anyone tell me the answer for theta?
-26 degree.
26 degree. Okay. Okay. 26 degree. ತಗೊಳ್ತೇನೆ ನೋಡಿ 26 ಡಿಗ್ರಿಗೆ ಇಲ್ಲಿ D, this is D, 60 degree Q ಅಲ್ಲ. Okay, so ಇಲ್ಲಿ I don't know the force. This is F23. Here I know the force, that is F43. Correct? F43 at an angle of ಹೇಗೆ ತಗೊಳ್ತೀರಾ ಇದು? C 26 ಅಂತಂದ್ರೆ ಪಾಯಿಂಟ್ ಇಂದ 26 ಡಿಗ್ರಿ ಒಂದು ತಗೊಳ್ಳಿ. This is theta. Okay, so you extend it. So this is what the extension. This force is F43. This is third link, right? F43. F43 at an angle of 26 degree, because this is theta. This is 20. This is 26. And extend it in the downward direction. F43. Okay. Now, in this system, link number 3 is a 3-force member, that is F43, Q and F23. 3-force member, a body with a 3-force member. What is the condition? Here we have 3 forces. These 3 forces must be concurrent at a point. It has to intersect at a point. What is the second condition? Summation of all the forces must be equal to 0. If these 2 conditions are satisfied, then the system will be in equilibrium. Here we have 3 forces. We need to find out the point of concurrency. Point of concurrency. How do you find out the point of concurrency? Look at this. I'll do it. I'll extend this line. Which one? F43. Okay. Write down below this. Link 3 is a member. Link 3 is a member with 3 forces. Therefore, for equilibrium, all 3 forces must be concurrent and summation of all the forces must be equal to 0. That is, force polygon must be closed. Must be closed. So if you apply these 2 conditions, we'll get the value of F23. Okay, how to find out the point of concurrency? To find, write down below this. To find the point of concurrency, POC. To find POC, point of concurrency, extend F43 and I'll tell you. Okay, F43 extend F43 till it intersects which line? Till the intersection of intersecting with Q. So it is intersecting at Q at this point. This point is called as POC, point of concurrency. POC, or you can take it as P. Not a problem. P. Is it okay? Or POC? POC is okay. P already we have mentioned in the fourth link, right? POC, point of concurrency. So these two forces are meeting at this point. Now, what about third force? Third force also has to meet this point only, right? So third force is here. So if you want to meet it, you just draw the line like this. So like this. So this is what the meeting point, point of concurrency. This is F23. F23 is actually acting in this direction, not in this direction. F23. Below this sentence, write down. Therefore, force F23, force F23 also meet at point POC. Therefore, F23 also meets at POC. POC. Therefore, join ಯಾವ ಪಾಯಿಂಟ್ ಅದು B and POC. B and POC. B and POC. B and POC. B and POC we have joined. This is P, right? B. Is it okay? ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಬೇಕು, ಇಲ್ಲ ಅಂದ್ರೆ ಕಷ್ಟ ಇದು. ಒಂದ್ಸಲ ಕಾನ್ಸೆಪ್ಟ್ ಗೊತ್ತಾಯ್ತು ಅಂದ್ರೆ ಈಸಿಯಾಗಿ ಮಾಡ್ಕೊಂಡು ಹೋಗ್ಬೋದು. ಹಾಫ್ ಆನ್ ಅವರ್ ಯು ಕ್ಯಾನ್ ಫಿನಿಶ್ ದ ಪ್ರಾಬ್ಲಮ್. You took around 2 hours. Okay. Done? Now, summation of all the forces must be equal to 0. Means we need to find out the value of magnitude of F23, right? Okay. Write down. To find F23, draw force polygon. Step by step ಹೇಳ್ತಾ ಇದೀನಿ. No need to write these steps. Directly you can do it. Okay. So force polygon. Scale. What is the scale you need to take? ಎಷ್ಟಿದೆ? 800. ಇದು F43 ಎಷ್ಟಿದೆ? 34 2250. 2250 ಇದೆ. 2250 means 500 is equal to 1 centimeter. First, F43. Okay. ಹೇಗೆ ಮಾಡೋದು? ಫಸ್ಟ್ F43 ಇದೆ. F43 26 ಡಿಗ್ರಿ ತಗೊಳ್ಬೇಕು. ತಗೊಳ್ತೀನಿ ನೋಡಿ. ಈಗ ಒಂದು ಲೈನ್ $26 degrees. This 26. What is the length? 2250. 2250 means 4 centimeter. 4.5 ಆಗುತ್ತಲ್ಲ? 4.5. Take 4.5 centimeter. F34. Sorry, F43 ಅಲ್ಲ? 2250 is equal to 2.5 centimeter. 4.5 centimeter ಅಲ್ಲ? ತಗೊಳ್ಳಿ 4.5 centimeter. ಇಲ್ಲೆಲ್ಲ ಕಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. Point A. Next. Q 800 ಇದೆ. $860 ಡಿಗ್ರಿ. 60 ಡಿಗ್ರಿ ಅಂತಂದ್ರೆ ಇದಕ್ಕೆ ಎಷ್ಟಿದೆ ನೋಡಿ ಆಂಗಲ್, ಅದಕ್ಕೆ ಹಾರಿಜಾಂಟಲ್ ಲೈನ್ಗೆ. ಇದು 60 ಡಿಗ್ರಿ ಆಯ್ತು. ಇದಕ್ಕೆ ಎಷ್ಟಿದೆ ನೋಡಿ ಈ ಆಂಗಲ್ 5. ಎಷ್ಟಿದೆ ಆಂಗಲ್ 5? ಹೇಳ್ಬೇಕು ಬೇಗ. ಆಂಗಲ್ 5 ಎಷ್ಟು ಬಂತು? ಇಲ್ಲ ಮಾರೆ. Can anyone tell me the answer for 5? ಎಂತ ಓದಿದಾರೆ ಅಂತ ಗೊತ್ತಾಗಲ್ಲ. ಒಂದು ಆಂಗಲ್ ಫೈಂಡ್ ಮಾಡಿ.
40.
40.
35.
Huh?
40.
35.
45, 35
40.
ಒಂದೊಂದು ಆನ್ಸರ್ ನೀವೆಲ್ಲ ಡ್ರಾಯಿಂಗ್ ಮಾಡಿದ್ರಲ್ಲ.
40.
40.
40.
Okay. 40. So 40. What is the length? 800. 800 ಅಂತ ಎಷ್ಟು ಬರುತ್ತಾ? 1 centimeter. 1.5. 1.6 ಏನೋ ಬರುತ್ತಲ್ಲ. Q is equal to 1.800 Newton is equal to ಎಷ್ಟು ಬರುತ್ತೆ? 1.6 centimeter ಬರುತ್ತೆ. This point is B. Next, ಏನಾಯ್ತು ಮಾಡಿದ್ದು? ನೆಕ್ಸ್ಟ್ F23 ನೋಡಿ. ಮುಗಿಯುತ್ತಮ್ಮ ಈ ಪ್ರಾಬ್ಲಮ್. F23 is it meeting at point C? Sorry, point O. ಪ್ಯಾರಲ್ ಡ್ರಾ ಮಾಡ್ಬೇಕು F23 ಗೆ, ಪ್ರೀವಿಯಸ್ ಫಿಗರ್ ಗೆ. ಜಾಯಿನ್ ಮಾಡಿ ಇದಕ್ಕೆ. ಇಲ್ಲಿ ಪಾಯಿಂಟ್ ಸಿಕ್ಕಿತ್ತಲ್ಲ B. So because it is a 3/4 number, need to join this. So this is what? F23. 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 So you can measure the angle. This is gamma. Now tell me the answer for gamma. What is F23 answer? F23 is equal to, this is OB into scale. Now tell me the answer for OB. Answer for OB. Can anyone tell me the answer for OB? Hello? OB length?
5.4.
3.4. Exactly.
5.4.
Huh?
5.4.
5.4. Okay. 5.4. Into scale is 500. Alla? Answer F23. 20.
2700.
27.
00.
00 Newton.
Yes, sir.
Correct, Allah? This is actually downward, right? Downward. So next step, all of you copied? ಕೆಲವರೆಲ್ಲ ಕಾಪಿ ಮಾಡ್ಕೊಳ್ತಾ ಇದ್ದಾರೆ ಅಲ್ಲಿ, ಆನ್ಸರ್ ಮಾಡ್ತಿಲ್ಲ. ಮೋಹಿತ್ ಇಸ್ ದೇರ್? ಜಿತೇಶ್ ಯಾಕಮಾರ ಇವರು ಕ್ಲಾಸ್ ಅಲ್ಲಿ? ಜಿತೇಶ್ ನಮ್ಮ ಹೊಡಿಬಲ್ ಕರಿತಾ ಇದ್ರೆ ಮಾತಾಡಲ್ಲ ನೀನು, ಮತ್ತೆ ಯಾಕೆ?
ನೆಟ್ವರ್ಕ್ ಇಶ್ಯೂಸ್ ಕೇಳ್ತಿರ್ಲಿ.
ಏನ್ ನೆಟ್ವರ್ಕ್ ಇಶ್ಯೂ? ನಮ್ಮರ ಕತೆ ಹೊಡಿದ್ರಿ ಬೈ, ಎಲ್ಲ ಹೇಳೋದು ಇದನ್ನೇ ಹೇಳೋದಾಯ್ತು. ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಇರ್ತೀರಾ, ನೆಟ್ವರ್ಕ್ ಇಶ್ಯೂ ಅಂತ ಹೇಳ್ತೀರಾ. ಫಸ್ಟ್ ನೆಟ್ವರ್ಕ್ ಇಶ್ಯೂ ಬಂದ್ರೆ ಕಾಲೇಜ್ ಬಂದ್ಬೇಡಿ, ಇಲ್ಲಿ ಆಫೀಸ್ ಇರ್ಬೋದಲ್ಲ. ನೆಕ್ಸ್ಟ್ ಲಾಸ್ಟ್ ಸ್ಟೆಪ್, ಕನ್ಸಿಡರ್ ಲಿಂಕ್ 4, ಸಾರಿ ಲಿಂಕ್ 2. ಲಿಂಕ್ 2 45 ಡಿಗ್ರಿ ಅಲ್ಲ? ಲೆಂತ್ ಎಷ್ಟಿದೆ? 3 ಸೆಂಟಿಮೀಟರ್. ಕರೆಕ್ಟ್ ಅಲ್ಲ? 3 ಸೆಂಟಿಮೀಟರ್ ಎ ಬಿ. Now at what angle this what is the gamma angle? Angle gamma, ಇದು ಬರ್ಕೊಳ್ಳಿ. angle gamma is very very important here. What is the angle gamma? Or you can take it as beta, no problem. Gamma or beta, no problem. I'll take it as beta. Okay, what is beta angle? What is beta? ಎಷ್ಟು ಡಿಗ್ರಿ? 11 ಡಿಗ್ರಿ. 11 ಡಿಗ್ರಿ. ಓಕೆ, Next, so here we have a force, right? F. This is link number 2. F link number F32. F32 is equal to F23. Okay. So therefore, write down F32 is equal to F23. F23 we have found, that is F23 is equal to 2700. F23 is equal to F32, but it is opposite to direction. Downward that it is upward. Upward. Because here we have taken it as downward. It is upward now. So F23 upward means, so I will take a reference line here on the vertical line. Horizontal line. So gamma or the beta is 11 degree. Take 11 degree line. So this is my 11 degree line. Take beta is equal to 11 degree. So this is what the force F32. It is opposite to F23. So here we have a torque T2. And we have one more force, that is actually it is a zigzag F12, but it is a 3-force member, right? Write down the comment here. Link 2 is a member with 2 force. What are the force? F32 and F12, and a torque T2. What is the condition for static equilibrium? A member with a 2 force and a torque equation, same as the previous problem. These two forces are equal and opposite. Equal ಮತ್ತು opposite ಅಂತಂದ್ರೆ ಏನು? ಇದನ್ನ ತೆಗಿಬೇಕಾಗುತ್ತಾ? So F23, sorry, F12 should be equal and opposite. Parallel ಆಗಿ ಡ್ರಾ ಮಾಡಬೇಕು. Equal and opposite and parallel. Correct ಅಲ್ಲ? Opposite ಅಂತಂದ್ರೆ if it is upward, it is downward. F12. Equal and opposite. So, and the couple formed by these two forces is equal to the applied couple. Applied couple is T2. So therefore, for equilibrium, F32 and F12 are equal, opposite and parallel. Correct? Parallel. Equal, opposite and parallel. Therefore, you can write it as F12 is equal to F32 is equal to 2700 Newton. F32 is upward, F12 is downward. Correct ಅಲ್ಲ? Please copy this, do it fast. ಏನಿಲ್ಲ, ಫಸ್ಟ್ 2 ಸ್ಟೆಪ್ ಮಾತ್ರ ಇಂಪಾರ್ಟೆಂಟ್, ಮತ್ತೆ ಆಮೇಲೆ ಮಾಡ್ಕೊಂಡು ಹೋಗ್ಬೋದು ಅಷ್ಟೇ. Finished? ಆಯ್ತೇನ್ರ ಮಾತಾಡ್ರು ಮರ. ನೆಕ್ಸ್ಟ್ ಸೆಕೆಂಡ್ ಕಂಡೀಷನ್ ಏನು? couple formed by F12 and F32 is given by, what is the couple? C is equal to F12 into H1 is equal to F32 into H1 is equal to, what is the value of F1 H1? How to find out H1? Just extend F32 extend ಮಾಡ್ಕೊಳ್ಳಿ ಹೀಗೆ. ಸೊ ಇಲ್ಲಿ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಲೈನ್ ಡ್ರಾ ಮಾಡಿ. ದಿಸ್ ಇಸ್ H2. ಯಾಕೆ ತಗೊಂಡಿದ್ದೀನಿ ಅಂತಂದ್ರೆ H ಅಂತ ಆಲ್ರೆಡಿ ತಗೊಂಡಿದ್ದೀನಿ ನಾನು. ಸೊ H2. ಓಕೆ, ಇದು ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಇರ್ಬೇಕು. ಆಯ್ತಾ, ಚೆಕ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಎಕ್ಸಾಕ್ಟ್ ಬರಬೇಕು. ಒಂದು ಸ್ವಲ್ಪ ಹೆಚ್ಚು ಕಡಿಮೆ ಇರ್ಬೋದು, ನಾನು ಫ್ರೀಹ್ಯಾಂಡ್ ಸ್ಕೆಚ್ ಮಾಡ್ತಿರೋದು. H ಅಥವಾ H1 ತಗೊಳ್ಳಿ, ತೊಂದರೆ ಇಲ್ಲ. H1 F12, what is the value of F12? It is 2700 into H1 value. Can anyone tell me the answer for H1? Finished? Can anyone tell me the answer for H1? Hello?
Two point three.
Huh?
2.3. 2.3. 3.
Okay, into scale equal to 2700 into 2.3 into scale 100 ಅಲ್ಲ, 100 by 1. ಎಷ್ಟು ಬಂತ ಆನ್ಸರ್? Yashwant, answer. Yashwant, answer ಇದು. ಗೊತ್ತಿಲ್ಲ ಸರ್.
6,21,000.
ಅಷ್ಟೊಂದು ಬಂತ ಹೇಗದು ಮರ? ಸ್ಕೇಲ್ ಕನ್ವರ್ಷನ್ ಇದೆ. ನ್ಯೂಟನ್ ಮಿಲಿಮೀಟರ್ ಅಲ್ಲ. 6,000 ಎಷ್ಟಿದೆ? 621,000. ಸರಿ ಇದಲ್ಲ? 2,700 800. ಓಕೆ. ನ್ಯೂಟನ್ ಮಿಲಿಮೀಟರ್ is equal to 621 Newton meter. Correct ಅಲ್ಲ? Clockwise or counterclockwise? You check this. The force is like this and this force is like this. So the couple will be C. It is counterclockwise. Counterclockwise. Show it in the figure also, okay? Counterclockwise. Therefore, the last step, C is equal to T2 is equal to 621 Newton meter clockwise. Finished? So,
Yes, sir.
okay. There are so many problems out there. The next problem, I'll just give you the question and we'll do it in the next class. Okay. Problem number, I think 3, correct? 3. Please copy this problem. Also a typical problem. It is asked in the previous question paper. You see. Copy this. Angle is 30 degree, 30 degree. A, O, this is 60 degree. B, this point is C. For the mechanism shown, find the required input torque for static equilibrium, length OA and AB is equal to 250 mm and 650 mm respectively. Force F is equal to 500 Newton. This is the question given in the problem, or details given in the problem. This will be the last problem on single threaded crank mechanism. Copied? Finished?
Sir.
Okay, just a minute. Now it is 36. Okay, thank you. Those are finished. You can leave.